All right, so we're just going to hit some of the more basic information about the if elif else statement that I just showed you in coding. So again, this is a special version of the decision structure, but it's all together. And again, you can insert as many of these elif clauses as you want, as many as you want. You can have 1, you can have 50, you can have 1,000. Doesn't really matter. If you have a lot of things to check, you can really bloat that out pretty bad. Okay, so you want to keep it efficient, you want to keep it good, but you can add them in if needed. Okay, now again, alignment used with if elif else statement is really important. So if, elif, and else clauses are all aligned, conditionally executed blocks are consistently indented 1 tab. Okay, now again, if elif else statement is never required, but it can be a little bit easier to use. Okay, so now we're going to move here into logical operations and logical operators. Okay, so just quick definition. Logical operators are operators that can be used to create complex Boolean expressions. Okay, so we have relational operators, which is sort of determining the relationship between variables, right? Now we're going to talk about logic, like how do we logically think about these things? And in computer science, when we talk about logic, we're usually meaning like Boolean math, essentially, where we're like, if this and this is true, then this, right? Or if this or this is true, then this. Or if not this and this are true, then this, right? So for instance, if I'm trying to evaluate how cool somebody is, right? So if cool shirt is true and cool shoes are true, then this person is cool, else this person is not cool, right? So we can actually use this logical and or not sort of things to determine whether things are true or not, right? So these things are called logical operators, operators that can be used to sort of build out complex Boolean expressions, because now I can say if this thing is true and this thing is true and this thing is true, then I can evaluate that, okay? And this is actually a way to alleviate nested if statements even more. Okay, so here you see we have an and operator, we have an or operator. Okay, so these ones are binary operators. Essentially, they connect two Boolean expressions into a compound. So, if cool shirt and cool shoes, right, is true. The not operator is unary, and unary just means it's like by itself. So I can say if not cool shirt, right? So let's say I have this awesome shirt on. If I say if not cool shirt, that means it'll sort of negate that. So if the cool shirt is true, then it'll not that, and it'll sort of reverse that. Okay, and we'll go into that more, and I'll show you that they're called truth tables. All right, so first we're going to look at the and operator. So as we're talking about the and operator, it takes two Boolean expressions as operands, and then it uses this little thing called a truth table to determine, what the output is. Okay, so with an and operator, the only way you can get a true is if both things coming in are true. Okay, so if cool shirt and cool shoes, then you are awesome. Okay, so if I don't have a cool shirt, that means I'm not awesome. If I don't have cool shoes, that means I'm not awesome. It doesn't matter if I have a cool shirt and uncool shoes. I have to have both of those things being true. So again, the truth expression is, so if false and false, then it's false. If false and true, then it's false. If true and false, then false, then true and true, and then true. And I'll show you this in an actual Boolean expression. So if you're feeling a little confused, we're just going to go ahead and jump in and sort of show you this. Okay, so heading over to PyCharm, let's go ahead and just do this very simply. Okay, so we're going to create a simple decision structure. Okay, so I'm going to set that up like this. I'm going to throw a pass in there. I'm going to do this else, and then I'm going to throw a pass. Okay, so I've created this decision structure. Now, let's go ahead and build out the first Boolean expression. We can say if name is Adam. All right, so that's the first thing we're testing. That's all cool. It's all well and good. We've seen this before. Okay, so if name is Adam, we're going to jump right into this line 5, and we're going to execute everything that is indented below it. Right? But let's go ahead and we want to have something a little more complicated. We want to make sure that my name is Adam and my age is greater than 15. Well, I can use the keyword and I can say int, right? Because we know age is going to be a string. I can say if int age is greater than, I think I said 15. All right, so now we have a more complicated Boolean expression here. If name equals Adam and age is greater than 15, then we're going to go ahead and do a print statement here. You passed, whatever, okay? Otherwise, I'm going to do a print statement here. You failed. All right, it doesn't really matter, but it just to demonstrate sort of how this works. Okay, so in the logic of this, if we were to go back over here, we have two expressions, false and false. Well, we have A and B, expression A and expression B, okay? So in here, I have expression A and expression B, okay? If we were to break this down, expression A is name equals Adam, right? Okay, so that's expression A. And actually, I'll just put A with an arrow there. All right, now expression B is the age one, right? So expression B is int age greater than 15. Okay, now in order to make this true, both of these things need to evaluate to true. Because if we look at that truth table, expression A and expression B need to evaluate to be true, right? Okay, so name needs to equal Adam, and age needs to be greater than 15 in order for these things to prove to be true. And just to go ahead and show you this, I'm going to go ahead and print the evaluation itself. Name equals Adam, okay? And I'm also going to print int age is greater than 15. Now, because I just put these in the print statement, it's going to convert the Boolean value that comes out of this into output, okay? So here, we should always see true, true, okay? Down here, we should actually to save time, let's just go and just copy paste it. Down here, we're going to see all the other values, right? True, false, false, true, so on and so forth, okay? So let's go ahead and test this right here. Let's make both of these true. So let's go ahead and run this. So we're going to say Adam. Okay, so that means that first one. Now, I don't put a space on the end. Keep in mind. Just Adam. Okay, and I'm going to do 20 as the age. Okay, so name is Adam and age is 20. So we should see you passed, and then we should see true, true, correct? Okay, so we're going to hit enter. All right, so it says you passed. We know the first one evaluated to be true, and we know the second one evaluated to be true. So again, if we go to our truth table, here we have true, true. So the outcome is true. Okay? Now, to show you even further, just to demonstrate, I can actually copy this whole evaluation into the print statement. Okay, so this should also be true, right? So let's go ahead and evaluate this and put it down there. Okay, so let's run this again with the same input. Adam and 20. So we have name is Adam is true, age is greater than 15 is true, and so true and true, so true and true equals true. Okay, so let's go ahead and demonstrate this a little bit differently. Let's say John and 20. Okay, it says you failed, right? Because true and true didn't happen, right? So I got a false. So the name actually, again, Baymax is saying hi to all you. Name is actually John, all right? So we failed that one. Name is not Adam, okay? But the age is actually greater than 15. So we have false and true equals false. So if we go back to our truth table, false and true generates false. Okay, so let's try this to get false, false. So John and 1. False and false is false. So now let's make it Adam and 1. So now we have true and false is false. Okay? So that's the way the AND table works, and that's the way you sort of understand it. Expression A and expression B, okay? If it's false and false, false. If it's false and true, false. If it's true and false, false. If it's true and true, true. Okay? I want you to really digest that, spend some time really thinking about that, because it's a very, very important thing to understand in terms of logically designing your program. And again, with this example right here, you can see A is if name is Adam is true and age is greater than 15 is true, then we're here. So true and true equals true. So then I can come here. Otherwise, come down here. Okay, now I can do an elif to define other things if I want to, but this is sort of how the AND operator works. Okay, so moving on to the next one here, we have the OR operator. Now, the AND operator, the only way you can get a true is if both A and B are true. So if name is Adam and age is greater than 15, then we get a true. Otherwise, we get false. And or, the only way you can get a false is if both A and B are false. Okay? So if I change this to an or, right? So now when I evaluate this, if name is Adam, if name is not Adam, and age is not greater than 15, then I'll get a false, then I'll get a false, right? So if name is not Adam, or if name equals Adam is false, and age greater than 15 is false, then I'll get a false. Otherwise, I get a true. So, because it's or, if name is Adam or age is greater than 15, then you get a true, right? Because it's just sort of the or, just like in the English language, okay? So we should be able to test this out. We should get a lot of trues here, okay? So let's go ahead and do Adam and 20. Obviously, we have true, 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 okay? That's an easy one, true, true, and true. Okay, so let's go ahead and try to make name not Adam, but we're older, okay? So name is not Adam, so we have a false, and then we have a true, right? So then our output here, oh, I'm sorry, the output, I didn't change these here. Sorry, let me run that again so you can actually see what's going on. All right, so we're gonna run that again. So Adam, and then 20. All right, so we have true, 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 right? And then we can actually do John and 20. Okay, so we have false, true, but also a true. Okay, then we can do Adam and 1, right? So we get true, false, but we still get a true, right? We passed. So the only way that I can fail is if I have John 1. Okay, so you failed, false, false, false. Okay, so that's the way that that works. So you only get false if both A and B are false, if you have false and false inputs. Okay, so that's the OR operator. Now, in terms of sort of how we evaluate these things, the way the Python works is it uses something called short circuit evaluation. So essentially, you decide the value of the compound Boolean expression after evaluating the one sub-expression. So, for instance, for the OR operator, if the left operand is true, then it's true, right? We don't need to go evaluate the right. For the AND operator, if the left operand is false, we don't need to evaluate the second because the expression is false, okay? All right, so again, we have this final unary operator, which is the not, and essentially it just reverses it, right? So if name equals Adam, if not name equals Adam, we'll just switch false to true and true to false, essentially. And that's exactly what we could do here, or not, okay? So you just use that not operator, and that'll actually switch that, okay? So if we run this, let's go ahead and do Adam and 20. Okay, so I want you to think about this, critically evaluate this. Okay, so this first evaluation, Adam, is equivalent. Yes. So actually, let's change this back to and, make it a little bit more complicated. And not. Okay, so we have an and, so we know that it needs to be true and true to get a true. So to get into here, I need to have true, right? So here I have Adam, so that is going to be true, right? So then over here I have 20. 20 is greater than 15, but then I not that. So I'm going to get a true here, but then I'm going to turn it into a false, right? So if our evaluation is correct, we should actually fail this, right? But we didn't. Okay, so what ends up happening is the evaluation actually evaluates this first and then evaluates this. Okay, so it's a little bit off. So in order to make this work, you actually have to use parentheses, okay, to make sure that these things are actually knotted. Okay, so there you go. There's your not and your and your or and your logical operators. So again, the last thing that we're going to cover with the last little bit of time here is checking numeric ranges. I'm actually going to do that in a separate video. It'll be a really short one, but we're running a little long on this one. So we'll be right back. Go ahead and play around with those logical operations, and then we'll see you in the next video.